pleasantly surprised at 3. Usually what happens in this first section is most people tend to go rather quickly through it. There's not a lot of crazy right off the bat here. We're going to rename a few things instead of taking a square root or a cube root. We're going to start calling them n roots. And it's a very simple way to get used to how it's going to look. It's going to be this. It's the nth root of something. The nth root, where this value of n is going to be any number. Okay? That value of n can be 2. If the value of n is 2, it means it's a square root. The value of n is 3, it's a cube root, and so on. Did I expect this? Yeah. So what we're going to do is we're going to look at something like this. What is the fourth root of 81?
3.
The fourth root of 81 is basically asking you the question. I hear you guys giving me the answer already, which you're right. What are 4 numbers that you multiply together that are the same that get you 81? 3, 3, 3, 3. Okay? So this could equal 3. Or what else could it be? It could be negative 3 as well. Now, when we get into this chapter a little bit more, there's going to be a time and a place for the plus minus. Okay? Usually what happens when you're dealing with these for giving the plus minus solution is when you take the square root over, or an nth root over an equal sign. When you're trying to just solve something, we're usually looking for just the positive value, or in some cases we might be getting the negative value. When you do something that looks like this, though, if you're solving an equation, what would you have to do to get x by itself? And when you do that, you have to do that to both sides of the equation. Right? When you're doing this root over the equation, over the equal sign, that's generally the rule for when you do that. Okay? Does that make sense? It's a little bit different than, what's that? It is. All day. It's a little bit different than taking that. The cube root of negative 125. What are 3 numbers that have to be exactly the same that multiply together to get you negative 125?
Negative 5.
That's not going to produce an imaginary root.
It is not. Why is this not going to produce an imaginary root?
Because it's cube.
Because odd.
Because it's odd. Yeah. What happens here is you get these rules, and the rules are written out kind of weird, and I'll do it this way. If you have an even root of a negative number, there is no real. Yes, you have an imaginary solution. We're not looking for imaginary solutions right now. I don't care about that. Not to say that they're not important. They're just forgotten. But an odd root of a negative a value is okay. God bless you. Remember, when you take any odd roots of a negative, we'll come out with a negative answer. Because when you're multiplying 2 negatives together, it becomes positive. But if you multiply a number of odd value negatives, it will always be negative. That's why this is going to be okay. All right? Does that make sense?
Yeah.
Yes.
All right. So that's kind of one of the rules that you're going to see. I don't think that's going to be a big deal. We use this a little bit more even in the 7-2 when we start working with simplifying monomials with rational exponents. So it's very easy to see how this works. Which means that we can rewrite things in different terms now.
Are these formulas?
Kind of. It's called a rational exponent. A rational exponent is a fractional exponent. A fractional exponent is an nth term or an nth root problem.
So exponent of 1/2 would be a square root.
Correct. All right. Exponent of 1/3 would be cube root. Where this value of m, it works out to look like this. It's the nth root of some number raised to that m power. When you do a couple of these, you're going to just find out real fast that they're very, very easy to work with. Okay? You see them written back and forth a lot of times in and out of this exponential form to nth root form. They mean the same. All right. For example, if I want to just rewrite something, if it was 8, excuse me, to the 2/3. 8 to the 2/3 is the cube root of 8 squared. And what's the cube root of 8 squared? 4. And the reason that it's 4 is because you start with your innermost parentheses and work your way out. Yes, there will be calculator, non-calculator with some of these things. You're going to be able to take cube roots of some values that are be easy to work with. Cube root of 8 is 3, but we should all know that.
Don't do that.
We should all know. So you do what's inside the
We
parentheses.
should all know that, yes.
So you do what's inside the parentheses
Yeah.
first.
You work your way out of the parentheses, is all you're doing.
Are you expecting us to just put these through a calculator?
No, in your brain. Some of these things you're going to have to, yeah, they'll be calculator, non-calculator. And once you practice a few of these, you're going to see how very simple they are. All right. It also works the same way if you're working with a negative exponent. If you have a negative m to the n, a to the negative m over n. Anything that has a negative exponent means it's not happy where it's at, correct? All right. So what you would do is just write that as 1 over a to the m of the n. And then we simplify that to the nth root format.
And if they for the m.
Yes, ma'am.
Why do we move the whole equation under the 1? Shouldn't it be, or couldn't it be a to the 1 over 3 and n?
No, because what happened here if it was 3 to the negative 1? See what I'm saying? They became 1/3. It just so happened that this fractional exponent was negative 1 over 1. That's all. Okay. So you work through some of those. As we get into working with some of them, you'll see they're not that difficult to be able to calculate in your head. I hope. So let me show you.
You can only hope.
Yeah. If I look at these three, if I have 9 to the 3/2,
Then that's 9 square root of 9 to the 3rd power.
correct. When you rewrite that in terms of nth root, it's the square root of 9 cubed. Now, usual etiquette here, you don't have to put the 2 as the nth root. You don't put the 2 in front of there, because it's implied that that's what that means. All right? And square root means it's the half power.
So it's
Does it matter?
27.
Yeah.
Correct. It doesn't matter to put it in, no. It's fine. So you wind up, square root of 9 is 3, 3 cubed is,
Why did you do a slash fractions?
what's that?
Why did you do a slash fractions?
They use it because it saves space. Really, that's really the only reason they put slash fractions in there, is because it does save a little bit of space.
Monsters.
I know. Next one, you have 32 to the negative 2/5.
And
What do you have to do right off the bat?
fifths, or of 32.
Put it under.
It's got a negative exponent. Negative exponents aren't happy. Make them happy. Yes, ma'am.
With these fractions ones, couldn't you just like subtract 1 from both of them? And that's like you take that 1 away from that, so then it's 2, and it's 2 over 1, so then that would just be 9. I don't know.
Yes, sir.
How would we get 27? Square root of 9
3. What's 3 cubed?
So is that 2? Wait, so is that 4 then?
Hold on, hold on. About order of fractions when you have order of operations with fractional exponents, or when we had what'd you get? X cubed, right? Same base, you add the exponents. Can't they do that there by splitting them apart? What's 2 to the 2? What's 2 over 2?
1.
What's 9 to the first power? 9. What's 9 to the half power?
4.5.
No.
Oh, sorry.
3. What's 9 times 3? 27. I think I kind of thought that's where you were starting to
Yeah,
think about.
that's what I
And
read.
these are properties that we'll do on Wednesday and Wednesday too. Okay,
Oh,
so
sorry,
there are
crazy.
some, you're not totally crazy, just kind
I'm
of.
curious, do you have any plans tomorrow about what we're going to be doing since you're not going to be here?
More of this stuff. You're the math team. So in this case here, what's the 5th root of 32?
2.
2. What's 2 squared? So the denominator becomes 4, the numerator is still 1. So the answer is not 4, it's 1/4.
Will this kind of question be on the non-calculator or the calculator?
What do you think?
Calculator.
All right. And then lastly, the cube root of -8. What are 3 numbers that are saying that you multiply together to get -8?
2.
What's -2 to the 5th power then?
Negative 32.
There you go. And yeah, these are the types of things that you'll see them mix out where it's going to be the non-calculator. Okay?
I could sit there staring at that number 32 for like 10 minutes.
Well, you have to think about it in terms of just number sense.
But I
It's-
don't.
Well, it should be not that bad
I
because,
don't numbers necessarily.
well, you know it's not going to be 1, right?
Well, obviously.
Okay, and you know it's not going to be 5.
Sure.
So you think it could be 4? Because 4 to the 5th power would be the same thing as 4 squared
But
times
see,
4
I'm not going to go
squared.
through this thought process. I'm going to sit there and look at the paper and be like, oh my god, how did I get here?
Then we do some other stuff with the approximations. There are going to be times it's going to ask you for approximate solutions, approximate answers. And usually when we're talking about approximate answers, we have to know how to enter these values into the calculator. Tonight when you have homework problems, there's going to be certain problems that you'll have. I'm going to ask you to give me exact and approximate answers. You have done exact answers before. You know when you had to simplify, you did square root of 8, you'd write 2 root 2? Or you'd have to write out the decimal version of like 2.7 or whatever it might be in that neighborhood. Well, it's the same basic idea here. When we do something like this, if I want to take the 4th root of 5 quantity cubed, I have to know how to use my calculator. I have to figure out how to put in my nth roots. So, there are a bunch of different ways to write this out. Your nth root button, just so you can know where it's at, you hit math.
And then you hit Y.
It's the x root, yeah. It's option 5. And if you look at it when you hit it just right off the bat like that, you'll notice that it's flashing the answer in front of the root. You have to backtrack it and overwrite it.
Or you can just put
I'm going to show that one next, don't worry. Turn it into a 4, put a 5 inside. And now you can hit the 4th root of 5. And just hit enter. That's just the 4th root of 5. It's just the 4th root of 5. What else do I have to do to it? I got to cube it. I just did the inner part first. And you see the 3rd power, and there's your answer then. So the 4th root of 5 is approximately 3.34.
If we put in a parentheses, we don't have to do 2 steps, right?
Correct. If you type it in the way that it's shown, it'll do everything for you. Now, in order to do that, it's a very similar to the way that you guys used the multi-view calculators last year. You had the X root or the X root button and all that. but you didn't have to put parentheses around it. This one you gotta put parentheses. So you'd have to just type in a parenthesis. You know that you're gonna use the fourth root, so you press 4, math, option 5, and it creates the fourth root right there. That's another way of doing it. Put in the 5, get out of underneath the radical, close the parenthesis to the third, and hit enter. You're going to get the same answer. If you type it correctly with the parentheses and all that, it's going to work just fine. All right? You just got to be careful with your parentheses and make sure you get out from underneath the radical. You seem amazed.
Do you ever think of like how calculators can be one
I
time
do.
to be alive?
It's pretty crazy.
How does it do it?
You know, like, and who invents a machine to do that?
We did program.
People who don't actually want to do that.
Right. People that don't want to do math.
They had
People like us.
Yeah. A lot of times these calculators, the calculators were derived from people that used what are called slide rules.
Oh,
I don't want your watch.
Yeah, those for quick calculations. And then after that, they started making computers, and they started to program computers. And the computer programs were a whole bunch of 3x5 notebook cards with hole punches in them. They used to read them that way. So you'd have stacks upon stacks of calculations that they would do to figure stuff out. Well, if you think about it, when NASA first sent people to the moon, the computers that they were using were punch card type of computers. The computing power in those supercomputers that which made them land on the moon were less than that of what is in this.
Maybe 21st century.
I'm gonna send my calculator.
no.
I mean, it's seriously, you have, and then that whole thing with the joke about being done with the slide rule, you have more computing power. The processors that's in your cell phones are stronger than what they had. I know, it's true.
How does it
I don't know, I never had to use one. So anyway,
I did the same thing twice. One, it gave me an error. The other one, it gave me an answer.
I don't know what it did. There might be some with a spacing or something. So I just wanted to show you how you set up an approximate. It's not that big of a deal. You'll see where this is going to come into play here in a little bit. For example, solving equations. Now, solving these radical equations, or we're using nth roots, if you will, you're gonna figure out they're really quite simple to work with. Okay. You've all solved equations before, multi-step problems. It's not that big of a deal. What's going to happen here is we're going to start working with the nth roots of them. So instead of taking the square root, you might take the third root, or the fifth root, eighth root, something along those lines. So in that first example, 2x to the fourth equals 162. What do you do first? Divide by 2. Good. You divide both sides by 2. You have x to the fourth is 81. And now how do you undo fourthing? You fourth root it. Bless you. Now notice, I took a square root over an equal sign. I have an even root. What do I do?
Plus or minus.
This is the situation you do plus minus then. You have plus minus 3. Why is that? Square root of 81 twice. What? Now, one of the things you have to remember to do is you will eventually be checking for extraneous solutions. Extraneous solutions is the answer that might be an answer, but it's not quite an answer.
Like that asymptote that might be there, but it also might not be there.
Exactly.
Or that number that might exist also might not exist. I used to like math, and then you started teaching me things that don't exist, Mr. Murphy.
I'm sorry.
Shut up.
I get over it. What do I do first?
Third root it.
Third root it, yep. I can third root it, I can cube root it, excuse me. Now this is going to be an example of a problem that you're going to write out both an exact answer as well as an approximate. Because is 10 a perfect cube?
No.
No. So I know that I'm going to get x minus 2 is going to equal the cube root of 10. How do I get x by itself? You add 2. So x is going to equal the cube root of 12.
I disagree with that.
Good. You're paying attention.
Oh, there you go.
Common form of this
Oh, I already wrote it down.
is you put
That's why we
the 2.
use pencil.
I don't have.
You put the integer values before any radical. That's the etiquette way of doing it, okay? Always put your integers first. So this would be what we call an exact solution. 2 plus cube root of 10. Yeah,
So how come you don't fourth root that one before you divide by 2?
because it's not just x by itself. You can't fourth root it until you move that over. It's the same problem you guys had when we had the 2. When you did that, you guys took the square roots and bad things happened.
The x has to be by 6. Alright.
So, in order to get the reason why I want you guys to do these approximate, or excuse me, the exacts, is you'll see exact answers on standardized tests. ACTs, things like that, they do exact answers for both radical things, as well as we get the trig stuff, when we start solving trig equations as well.
So we can't take it any further than that.
Well, this is your exact. The next part, I'd say, what is the approximate? Was it 4.15, I believe? Yeah. Your approximate, then you just type that in your calculator and get the approximate out. Sir?
Alright, so I'm taking the ACT on Saturday, so they would want the x equals 2 plus.
You will see it written as, sometimes you'll see it written as a solution like that, and sometimes you'll see it as the approximate. It just depends on the question bank. All right, I've seen it both ways. Just letting you guys know that you'll see them written out that way. Okay? But it's not bad. If that was a fourth root, what would be in front of the 10? If it was a fourth root of 10. I'd have to have plus minus there because it was an even root going over. Okay. When you take odd roots, you don't have to do plus minus. When you take even roots, you have to do plus minus.
Plus or minus.
It would be 2 plus minus 4.
What's the exact answer?
2 plus the cube root of 10. Yeah, Clay.
So you wouldn't have plus or minus 4.5, you'd have like two different answers, because you're adding two negative and you're adding two positive.
Right. In this case, you're just, since it's an odd root, when you take it over an equal, there's no plus minus.
Okay.
It's when there's an even root over the equals is when there's plus minus. Because your odd roots, whether this is a negative or if it's a positive, it's going to equal a negative or a positive. There's no can be either or.
But hypothetically speaking, for the last one, if it was a fourth root, then you would have 2 addition for the approximate.
Correct. You'd have 2, yes. If it was, yeah, well, I'll just write it out. If it was x minus 2 equals the fourth root of 10, then you'd have 2 plus or minus the fourth root of 10. And you've done that where you've had quadratic formula stuff. You'd have 4 plus or minus square root or something. Okay? So you've done the approximate stuff. We just didn't write it out all. All right? So, do those 4 real fast. Shouldn't take you long. Hopefully you got them right. Did you get 5?
Yes.
Yay! Did you get -1?
No.
Yes. Wait, why is the first one plus or minus?
Yes.
But wait, is that for the?
But it's an odd one.
Odd nth roots don't get plus minus. Even nth roots do. What happens here? What's the square root of 0?
You can't have plus or minus 0.
Here you get x to the 4th equals what? 10,000. Be honest, how many of you guys wrote 1,000?
Oh,
There it is. Own it. Own it.
no, I didn't, okay, I did my.
Don't rub it in my face.
Plus minus. And why do I have to write plus minus? Own the fact that you guys can't add 7 to 9,993.
I can't say
I can't math properly.
I did.
I did minus 7.
Because knucklehead said it was 1,000.
I just can't math.
All right,
Save marks.
let's make this more difficult.
Let's not.
Let's not say we did.
See what you remember about this. You're right.
Spoiler alert.
So you've got the square root of 56 minus x on one side and it equals x on the other. In order to solve these radical style equations, you've got to get rid of the nth roots. In this case, our nth root is a square root. Everybody agree with that? All right. So how do you get rid of a square root? Square it. So if I square it on both sides, what happens to the root? It goes away. Square root of junk squared is? Now what do you do? Factor. Set aside equal to 0 and factor. 0 equals x squared plus x minus 56. What times what is negative 6? Add together to get 1.
Negative 7 and positive 8.
Is it negative 7 and positive 8? I'm just wondering.
It's positive 8, negative 7.
So your zeros will be?
Negative 8, positive.
Now, once again, this is where it comes back to having to check for extraneous. So we have the square root of 56 minus 7. Does that equal 7? Well, square root of 49 is?
7.
It works. Square root of 56 minus negative 8. Does that equal negative 8?
Yes.
No.
We know it equals positive.
It equals positive 8. Why does it equal positive 8, not plus minus 8?
Because it's a positive.
What?
Because the world hates me.
Did I take the square root of both sides over the equal sign? No. I just took the square root of one spot. So the square root of 64 in this case, has to equal 8, which does not equal negative 8. Therefore, negative 8 is?
A phony.
It's a phony. You're right. It's extraneous. It's the answer that's not the answer, but it's still an answer that doesn't work.
It's a number that's not a number. It's not.
You see the extraneous solutions again quite often with the radical stuff.
Are we going to see them tonight on Friday?
You might. Yes, ma'am. What's the difference between these two statements? What do I have to do here to get x by itself? The square root of what?
Both sides.
Both sides. I'm taking the square root over both sides. When you take the square root over both sides of an equal sign, it becomes plus minus 8. When I'm doing this, I'm just taking the square root of 64. What's the square root of 64? 8. I'm not taking the square root of another side and solve for it. Does that make sense?
Yeah.
That's why I don't worry about that plus minus there. It's a little nuance that you just get accustomed to. All right. The more we do these types of equations, the better off you'll be. Right? What's that? No, here you go. Did you want to see that again? Here you go.
So my guess is tomorrow what you're going to give us are automatically more problems and whatever we don't get that is wrong.
Pretty much. Okay. You good? So try these bottom two real quick.
Oh, no.
Wait, the bottom two?
I'll put them on a separate sheet here for you.
Oh, that is BS.
Your board's a
Hey, watch your language, kid.
Yeah, come on. Relax. Try these two real quick and see what we do.
So let's say square root of negative.
It's square root of negative 1 minus k equals 3. It just looked pretty bad when I clicked it to...
That's actually pretty good.
Wait a second. Time out.
Okay, negative 10.
Square both sides. So you get negative 1 minus 9 equals k.
I did it the other way, I did
So you move, like add 3, subtract 9, to get negative 10 is K. Now, does it work?
No.
Yeah, this one works. The square root of negative 1 minus negative 10 is the square root of 9, which is 3.
Minus 10.
And that works.
So
negative 10 works. Do the same thing on the other side. You square both sides. Not done, guys. Come on. So you have 81 x over 7. How do you undo that?
It's called multiplying, not timesing.
Extraneous is wrong.
That's right.
In this case here, the negative 10, when you substitute back in, you get 3. Oh, I see what you're saying. Yeah, you kind of have to make sure. I know. All right. Let's do this. This is section 7.1.
And then I eat a bag of popcorn and go to bed.
I think it's 14 through 40.
That's how I
Bless you.
And then I get home and I have Netflix. So it's just
With those, do exact.
stand up like, did you do your homework? And I'm like,
So the 14 through 40 there, it looks like it's a ton. It's all evens here. These are the ones that you're just rewriting from the nth root to the exponent rule, from exponent to the nth root, and some simple approximations. The last grouping are your solving of the equations. Please give me both exact and decimal equivalencies of your solutions. Some of the solutions are going to come out where it says, x equals 3. Well, that's an exact and a decimal. It just so happens if it winds up being one of those weird ones, to give them both. Does that make sense?
yeah.
That's a lot of homework.
Should take you 15 minutes tops. Yes, ma'am. You stop.